Hello everyone, hope you guys are doing well. So continuing our journey, today we will be studying about so last time we studied coaxial cables, right, for data transmission. So now we will be using phone and cable networks for data transmission. Now telephone networks were originally created to provide voice communication. The need to communicate digital data resulted in an invention of dial-up model. With the advent of internet came the need for high-speed downloading and uploading. The modem was just too slow. The telephone companies added a new technology called as the digital subscriber line or DSL. Although dial-up modem still exists in many places all over the world, DSL provides much faster access to the internet through the telephone network. And this start of we first discuss the basic structure of the telephone network, and then we see how dial-up or DSL technology used these networks to give us access to the internet. Now, cable networks were originally created to provide TV programs, and for those subscribers who had no reception because of natural obstructions in the mountains. Later, the cable networks became popular with people who just wanted a better signal. In addition, cable networks enabled access to remote broadcasting stations via micro. We'll see what this is. Now, cable TV also. Oh, okay. So, cable TV. Yes, it's assumed. Again, then cable networks. Cable TV also founded a good market internet access provision using some of channels originally designed for video. Okay, so we'll be discussing what happens now. The telephone network. So we all know telephone. Now, what is the circuit switching? Okay, let's just do a. We haven't studied about switching, right? So let's just do what is switching and what are the different types of, like, why is there is a need for switching. Okay, switching. Now, basically, a network is a set of connected devices. When we have multiple devices, we have problem of how to connect them to make one-to-one communication possible. In a solution, one solution is to make a point-to-point connection between each pair of devices, a mesh or a central topology. These methods, however, are impractical and wasteful when applied to very large networks. The number and length of links requires too much infrastructure to be cost efficient, and majority of those links will be idle most of the time. Other topologies employing multiple, such as a bus, are ruled out because distance between devices is too large, right? And a better solution is switching. So what we do is a switch network consists of a series of interlinked nodes called as switches. Switches are capable of creating temporary connections between two or more devices linked to a switch. So what? So the problem here is if you use a network topology like star or mesh, the problem there is when we are dealing with communication in, say, between countries, at that time this at that time it becomes very impractical, right? You have a very large network to take care of. So then what we did is the solution to this is we started introducing switches. So then what we did is now we made a link. Now we made a switch network such that all these switches are capable of establishing temporary connections between two or more devices. In a switch network, some of the nodes are connected to end systems. So, for example, you see this is a switch, so this is connected to this end. So the ends are ABCD, and then you have a central switch. The problem with bus topology is, again, it's you can't have a single bus running across cities, right? That is highly impractical. Now traditionally three methods of switching have been important. So there are three methods: one is circuit switching, packet switching, and then message switch networks. Now you can say that virtual circuit networks have some common characteristics with circuit switched and datagram networks. First we discussed what is circuit switched. Today the tendency in packet switching is to combine datagram networks and virtual. We'll see. Networks route first packet based on the datagram addressing idea and then create a virtual circuit for the rest of the packets coming from the same. So the problem that we are trying to solve is how to establish the communication. Circuit switch. A circuit switch is basically switches connected by physical links. A connection between two stations is a dedicated part. For example, this is like a dedicated part. Now each link is divided into we have n channels, right? So you give each network a time. The engines and computers are directly connected to switches. We have only shown two end systems. The end system A needs to communicate with system M. That time that connection is established. Okay, this is called setup phase is resolved, and combination of circuits or channels defines the dedicated part. After the dedicated part, um, so what we do is basically um, we establish communication using this switch. This switches help us to. So suppose A wants to communicate with them. So then we have a dedicated part passing through a switch. Now in a trivial example, so for example, let's this is how like circuit switch must. Now what happens is data transfer. So once the connection is established, then the data is transferred. So then what we do is we divide the we have two types of multiplexing, right? Multiplexing is when you have multiple lines and then you want a time on that line. So there are two types. One is a time division and then another is frequency division multiplexing. So now the problem is this is a lower efficiency. The delay is minimum since the direct connection is there. So then what's the problem is you need to have like connection established. I mean physical connection needs to be established, right? But using switch, which is again a bit difficult. Now then we have packet switch networks. So we have datagram networks and virtual virtual circuit networks. So what we do is we need to send if the message is to pass through a packet switch network, it needs to be divided into packets. The size of the packet is determined by the protocol. This is located in demand. So then this is like a datagram network. So each what we do is instead of sending the whole packet, you send datagrams, like you divide the packets and send it. Then what we do is we mention, so like we have a router over here, and then this routes it. This kind of has address to the next node. So we say hop. That is called as an hop. The problem is the delay is more. Um, Virtual circuit networks. Now, as a circuit switch network, there are setup and okay, switches can be allocated. In datagram network, data packet size, like each data is divided into packets, and then and the packet carries an address in the header. However, the address in the header as low that is defines the next switch or channel that the packet should be take, and not the end to end. The reader may ask how the intermediate switches know if there is no final destination current packet. The answer will be clear when we discuss virtual circuit. As in a circuit switch, all packets follow the same path established. A virtual network is implemented in data link, while a circuit switch is implemented in the physical layer and datagram is on the network layer. But this may change in the future. So basically, this is trying to establish how the connection and how the transfer of information will take place. This is like going into details of switch. We do not need this much. So let's go back to Okay, so the internet came after telephone and cables. So now how so then people started to think like how should we make use of the existing telephone lines and cable networks for data transmission. Okay. So now how is a telephone network? Now basically circuit switching. Now, what happens is the telephone network at its beginnings in the 1900s. The entire network is okay, which was originally an analog system using analog systems. During the last decade, telephone network has undergone many changes. Now, major components. So, for example, you have three main local loops, trunks, and switching offices. The telephone network has several levels of switching, such as offices, tandem, and regional. So, what we do is these phones are connected to local offices. The officer or the person sitting here. So, let's see what is this local loop. One component of the local loop is it's a distributed cable that connects the subscriber to the nearest office. It's like a central location, and then it has a bandwidth of 4 kilowatts. It's interesting that telephone a number associated with each local loop. The first digits of a local number define the office. The next four digits define the local loop number. Okay, so okay. Now back in India, you had MTNL phone exchanges, right? So what he's saying is all the phones in that area are connected to that exchange. That is the end office. And then from there we have and then the number is assigned in such a way so that if we say if we say some number, then the first three digits is basically the phone define the office. I don't know if I can search. So let's see how to check office number in MTNL phone. And there is something called as directory search. Okay. No. It's in MTNL. No, this is is there a way we can do this? Oh, so see, this is how it works. So you have one, then you have office code. These are all, that's what he's trying to say. That the number will be define the local number. It defines which office, and then the next four is the local loop number. Now trunks are basically the medium through which connection between offices and regions are established. Switching offices to avoid having a permanent physical link between any two subscribers. The telephone company has switches located in a switching office. The switch connects several local loops. Okay, the LATAs. After the legislature of 1984, the United States was divided into more than 200 local access transport areas (LAT). The number of LAT has increased, and LATA is a small metropolitan region and can have one single LATA. Okay, a small area may have. Okay, now intra-LATA services. The service offered by common carriers inside a LATA are called intra-LATA services. The carrier that handles these services is a local exchange carrier. Therefore, Telecommunication Act were granted to single carrier. Now, this is a monopoly, right? After that, more than one carrier can provide services. So, what happens is he's saying in a particular area, previously only one carrier used to exist. But then this is like that carrier having the monopoly, right? So, what they did is they had something called as telephone exchanges. The latter services are provided by local exchange carriers since 1996. There are two types of so then you have something called as local exchange. So then this all goes to a local exchange, and then so this is in what happens. So first is these are at end offices. From there it's connected to random offices. Then you have point of presence, and then this is basically um, the exchange that is used to connect these two networks. This is basically how the data transfers. Okay. So initially there was only analog services, the dial up. Now what happened is we wanted to switch the traditional frequencies were between 3000 to 300, right? At this range for this all is used for where a great deal of interference and distortions can be accepted. As we've seen, digital signals require higher degree of accuracy for safety's sake. Therefore, edges of this range are not used for data communication. In general, you can say the signal bandwidth must be smaller. To denote that, the term modem is basically okay. So now what happened is what is a so he's saying why did we need a dial-up? The problem is traditional phone lines had a very small frequency range, and we wanted to increase this frequency range. So then we introduced something called as modems. Now what is a modem? A modem is a composite word. It has two functionalities: modulator and demodulator. A modulator creates a band pass. Uh, so the thing is, we wanted to switch from analog to digital. Why did we want to switch? Analog signals are easily um, susceptible to interference. So then we wanted something digital, right? Ones and zeros. So then, but then telephones used to directly give out electrical signs. So we need something to convert that electrical to digital. So then then we placed a modem. So what happened? What a modem does is, suppose this is your communication line. This goes to the modem, and the modem to this is digital. Now you need something that is analog, right? The electrical signal will flow through the wire. So then we send electrical. So then again at the receiver end this has to be converted back. So then so that is a use of a demodulator. Um, the DSL. This is something. Okay. Now after modems reach their peak, again we need something to provide higher speed access. So then we went in for digital subscriber line or DSL. The DSL technology is a set of technologies differing in the first. So we have different like ADSL, VDSL, HDSL, HDSL. ADSL, this is the first technology. This is asymmetric DSL, and ADSL is asymmetric communication designed for residential users, not suitable for businesses. So one interesting point is ADSL used existing local loops, right? But how did ADSL reach a data rate that was never achieved traditional? The answer is twisted pair local loop is actually capable of handling bandwidths, but the filter installed at the end of the telephone loop host limits the bandwidth to 4K. If the filter is removed, okay, so then we need something called as asynchronous adaptation just by removing a filter. So we needed something that is adaptive, and so we got ADSL. So then the next thing that we was is an ADSL modem. So what we did is we removed this what do you say, the filter, the ADSL light. So then we said, okay, instead of doing splitters and having everything else, we got a new technology called as ADSL Lite. So ADSL Lite uses basically, mm, what happened was is let's see about let's see something. Let's go here. So the first thing that we studied is telephone lines, right? The first thing is DSL. We came to DSL. Uh, DSL. So what is digital subscriber line? It provides internet access over telephone. Okay. So now, traditional telephone. Okay, other POTS uses copper infrastructure to submit. So we have these are circuit switched, a dedicated switch is a circuit switch. So so previously this has to be done. This circuit switching in telephone used to be done with the help of an operator. So I say circuit switched network telephone. Okay, let's see what does he mean by a switch. A switch is basically something that helps to establish connection. A switch is basically something that is used to establish and um, manage connection. So then, so let's see what is local exchange switches. So previously these were all done by humans, right? Okay, this is something I don't know whether if I could get a human operating. Do I have a yeah? So what you used to do? This is switches, right? And then it's connected to some other TNG Broadband. Why is it not working? Okay. Okay. So first thing that we so let's see so the first um I say mode of communication which was established was a phone network, right? It's the oldest, the OG, you can say. Now how did it work? Okay, so this is phone one, and then you add another phone. Let's control C. Okay. copy. So this is phone 1, and then the easiest way to establish communication is you connect these two, right? And then this is okay. Let's this is the easiest. So let's see, when was phone was invented by Bell. I guess phone communication invented. So it was invented in 1876 by Graham Bell. You have Bell Networks, right? It's named after this guy. This is so it came in 1876. Okay. So then the problem is this was only able to do local communication, right? We wanted something like, so this can only do communication at a local level. So our goal was to have communication between different regions. That was our goal. So what we did is we kind of made an hierarchy, right? We said, no. So we kind of developed this hierarchy. So say this is a phone exchange. So if you see exchange, English meaning. Exchange is basically an act of giving one thing and receiving another. You give something and you accept. Okay, so then we said, um, so I have two phones now. Copy. So what we said, this phone 1, this is in one part of the country, and so we could not use topology to connect it, right? Because again, having a so many physical wires is difficult, right? It's not practically possible. So what we did is these exchanges used to connect. So I used to dial up at the exchange, then this exchange used to pass the information. The problem is the person who is sitting here can listen to everything. So that says phone exchanges in olden days. Okay, so this is basically a phone exchange where a person will physically pick up your call, and then it'll try to put you to a switch, and the person who is sitting here, he knows like which. So you will say, you'll call up and dial up and say, connect me to a person. So then who is in London. So then the person will then physically put that wire into that particular jack, and then the connection will be established. This is how it looked. Okay, now yeah, this is basically so this is so this thing is basically called as a switch, as it is, on balls also you have switch, right? The 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 thing that it does is when the switch is connected, current flows. In similar way, whenever it is connected, that connection becomes active. Okay, but then we don't want um, so since that this is manual, right? We wanted these to be automated, right? So then we kind of build something called as automatic exchanges. It senses an off hook condition when the user removes the handsets. The exchange provides dial tone to indicate. So then pulses are sent. Uh, so then we started saying, let's use something called as automating. Uh, uh, but the thing is, how did the okay. How did automatic exchange identify which so when you dial a phone number, so each digit is linked to an exchange. Older systems and pulses, modern systems use ringtone signaling. Now the exchange receives and analyzes the number based on its okay. So this is basically um did automatic switching use. Why is it the same as virtual switching? I mean, am I doing it or not same? Okay. So then, so remember there is a person sitting, right, who can listen. So then next, what we did is we went to let these switches be automatic. So now comes a bit of automation. So we say let's have automatic exchange. What does this work? So we do based on the number dialed, we try number dialed, the exchange has a table which is used to identify codes and connect. So this is, remember, this is, we are still in 1880s, right? We haven't, internet project has, ARPANET has yet not been launched. So we haven't come yet to launching internet as officially. So this is again, I say, this is one line going and this is coming. This phone one. Okay. Now when was ARPANET date? Like when, so now see, it's in 21st November 1969. Remember this date. And phone has come in 1880s. So let's add another page. So let's have one. So let's set this text. I say phone date of discovery is 1880. That's like almost 1 century. And then the internet or ARPANET was started in 1969. So this is like almost 1 century, 100 years difference, right? This is in 18th century, this is in 19th century. Now the problem is, again, even though it was internet, there was some, we needed to establish communication, right? Ultimately it goes down to two things connecting with each other. But we already, so what we did is, since we already had phone lines, we wanted to use the phone lines for internet. Why isn't, since we wanted to use the phone lines for internet, so then, so how to do this is the question. The first thing that we came up was ADSL. So ADSL, what it did is, so the first thing we created was a DSL, a digital subscriber line. So why reason we are talking about DSL is, computer will only understand ones and zeros. Hence we started to talk about digital subscriber lines. or DSL, right? The main goal was right. This is digital subscriber line. Now remember why it is digital. Computer can only generate ones and zeros, which is digital signal. So then what was the first modem? The first modem, let's say the first uh, DSL modem. So this guy built the first DSL modem. So then okay, so then there were different types of DSL modems, right? Digital subscriber line. There are different of them. The first was ADSL. So now, so then we needed something like a modem which can, okay, computer can generate only ones and zeros, but wires carry only electrical, because we are trying to use the already existing phone lines. So we needed a device to convert digital to analog. This device is what we call as modem or modulator turned together as modem. Okay, so there are different types of so the first modem we have was ADSL. So this is the first modem that we had. Okay, this is like how a DSL modem looks like. You have power, Ethernet, USB. This basically indicates that digital to analog conversion, right? Uh, so then one yeah, so now we were like DSL. So the DSL light indicates digital transmission is active. Does it indicate that? Right. Yes, the DSL and the digital transmission is active, and it's functioning properly. This is basically an indication, right? So outages occur in ISP? First is basically for the physical wire getting damaged. Then there are ISPs. So ISPs is basically something called as um, it's basically most of the time is hydro related issues. Oh, we haven't come to internet, right? We are still on DSL. So let's see what is ADSL. Asymmetric digital is a type of digital subscriber technology. Okay. So what it does is, so how does ADSL work? It works by using spectrum above by used by phone calls. Okay, so remember we are going to pass phone calls and the digital data on the same line, right? So we need to separate them. The problem is uh, DSL. So the spectrum was just wider than ADS, the one that is used by phone. Is it? Yes. Okay. So this is the first technology was ADSL. That is asymmetric something. Asymmetric digital subscriber line, right? Yes, asymmetric. So this is the first one that we have is asymmetric digital subscriber line. Now the since this is also on the, how does the wire identify between DSL and one data? Both are signals, right? Uh, okay, so then what it did is frequency. This had a different frequency band. This had a different frequency band. Then we started using filters. Okay. So this is okay. ADSL between DSL signal and phone signal, since they are on the same line. The solution is they are operated on different frequencies. So what is asymmetric here? Uh, Is it related to the frequency plot or something? Okay, so the asymmetric is basically how the frequency allocation and is done. So the goal, it's asymmetric is okay. So then but how did we identify that? It's a relationship. Okay. Okay, so then the asymmetric is, so before having this asymmetric, we identified how internet works is most of the time we are downloading and not uploading. So we said let's have two speeds. So the asymmetricity is both upload and download speeds are this is we are already in the 19th century when DSL comes in. Okay, then first is ADSL, right? Then we went on to ADSL Lite. So ADSL Lite is like a light version. How you have 4G Lite. So ADSL Lite simpler and cheaper. So again we got this ADSL. And the problem is here we need to split, right, to divide the signals between the phone and DSL service, right, to avoid interference. So ADSL Lite we did not need that splitter thing. So then we came up with something called as ADSL Lite. This is better and cheaper version of ADSL. Then we came out with third thing that we had is HDSL. High bitrate, more speed, right? HDSL is basically more speed. So then we came up with something called as HDSL. So remember when we talk about speeds, the thing we measure is how fast digital data is sent onto the coax. So when we talk about speed, we say how fast digital data from computer is transferred to coax. That is what we mean by that bit rate. There is something, this is data transfer, right? We always talk about data transfer. What is this data transfer that we are talking about? Is that from modem to the network, how much fast is that what we can control? Modem to wire. Okay, when we say speed, we are talking about modem to wire speed, like how fast is the digital data converted and going. So is this measured in kbps? So remember, we are when we say speed, right? We always we say that how fast the digital data is converted and put on to the wire of the network. Just give me a minute. Okay, so you are trying to understand speed, right? So mm, so let's discuss something about speed. It refers because in the wire we can't control, right? And put on the wire. This is what we mean to say when we are saying speed. Because once on wire you can't control it. Let's enter it. So that comes here. Once on wire, either the wire is damaged, only then there will be a loss. So that is it. So what we mean by speed? Okay, so we were trying. Okay, so let's no. We said perfect. Okay, so now there are different types of modems. We said so. So we were with ADSL, right? So then we went with something called as HDSL. You know, better and symmetric speed, both upload and download. Then then we also had something called as HDSL, I guess. HDSL again, symmetric. So then, so HDSL is high bit rate. Yeah, more speed. This is all with respect to the modem. Remember, uh, called as high bit rate, hence HDSL. So then we went to something called as HDSL. This is symmetric DSL, where we said both upload and download and having same speed. Now then we went to VDSL. We said this is very high digital subscriber line. As you have a phone line, you say it's a digital subscriber line, or you say it's the internet. Yeah, that is the difference. Okay. Okay, then we have VDSL. Now cable TV networks. The cable TV network started as a video service provider but has moved to the business of internet. In this section, we discuss how TV per se, we discuss how these networks can be used to provide. Okay, so then again, in certain areas there were no phone connectivity, but there were TV. So when were TVs discovered? Let's see. When was the first cable TV network set up? Cable TV network first. So when was cable TV? Okay, so cable TV came in 1948. Again, this is still before internet. Internet is 96 something. So this is again. So you can say we came from phone to cable to internet, I guess. So can we say the discovery was was phone to cable to internet. This is how things progressed. First we had phone, then we came with cable, then we wanted something. We said, don't use phone lines. Now then we started using something called as coaxial. Okay, so for phone lines in 1800s were they coaxial in nature? Oh, so this is not coaxial, right? It's okay. So they were twisted pairs. Then we moved on to the moment we changed the transmission medium. We said, let's have let's have a coaxial cable. So then we are using twisted pairs of cable. So then we suddenly realized, let's change the medium. So then we came on to coaxial. Then we changed from twisted pair to coaxial cable. Okay, so we moved from now we are in coaxial cable lines. Oh, let's see. It's not coaxial. Cable TV. Not right. Cable TV started to burst. So initially it was antenna. You had that antenna system. So this is the broadcasting used to have the antenna. Then this is the. So remember we are having coaxial line over here. So we kind of moved from twisted pairs to coaxials. Okay. So then we had something called as high fiber coaxial network. You can we'll see this thing later on. Okay, now we wanted to use this coaxial cable for data transfer, right? Now cable companies are now competing with telephone companies for residential customers who want high-speed data transfer. DSL technology provides high data rate connection is residential subscribers who will local power. DSL uses the existing unshielded twisted pair, which is very susceptible to interference. This imposed an upper limit on the data. Another solution is the use of cable TV network. So then what happened is mm, twisted pair is very susceptible, right? Very susceptible to. So at that time we had something called as okay. So we were all also laying down coaxial cables for TV. So we said why not use this cable which has less interference for internet. So now we wanted to use coaxial cable to do our internety thing. Okay. So now to use a cable for data transmission we need a key devices, a cable modem and a cable. Now what is this CMN? Now this is something this is how uh, today's internet works or how ISP uses it. Okay, now to use network for transmission we needed two devices, a cable modem and a cable modem transmission system. The cable modem is installed subscriber premises. It is similar to ADSL. The cable modem transmission system is installed Inside the distribution hub, it receives data from internet and passes them to combiner, which sends them to subscriber. The CMTs also receive data from the subscriber and passes them to the internet. So, the thing is, why did we need CM and CMTS? Why? What is the need for CM and CMTS? The need for cable modem arises from the use of internet, which is coaxial cable networks to deliver broadband internet services. These two components are okay, cable modem is a device. Okay, so as we are changing the medium, now we are using coaxial cables, right? For cable. So now there is something we needed it since the medium changed. Devices also have to change now. So the DSL could only connect to twisted path as DSL. Oh, which is inside RJ45, I guess. Yeah. So remember, okay, let's see the type of connection. Page 5. What happened? We went to down. What happened? Where did, let's go back to okay, yeah. Okay. Now uh, let's see how our DSL is connected. So DSL modems only have 3 inputs. So I can say one is power, then we have something called twisted paths, which are in phone lines, which are used for communication by connecting it to RJ45 cables. And then, yeah, we basically have these two things. Well, let's not have 3, let's have 2. Let's get rid of space. Let's now go down. What happened to this? So here we had HDSL as well, right? Let's type HDSL. HDSL. Then we had VS DL. So then let's go and type here. Now by that time, cable TV became popular. Again, why we use coaxial for cable TVs? Um, because for frequency we cannot use twisted pairs. They carry high frequency signals, right? Yeah, hence we don't use twisted pair because there's a lot of so TV broadcasting we need high frequency shielding, right? Twisted pairs won't provide me that. So the way we used to have is, you know, so let's have this as weight. So you used to have a broadcasting station somewhere. Let's this is the magic pen. That's good. So let's try this. Let's see what rectangle. So this is you have broadcasting station. Get this. So what happens is this is the satellite, and then this is home antenna. So what happens is you go from here to here and from here to here to this. This is how, and now this has to be something which is capable of withstanding high frequency. Capable of withstanding high frequency, and so we change to coaxial. High frequency means better speed, right? This is a coax. So all this is a coaxial cable. So then we realized, why don't we use this? Why not use coaxial cable for internet instead of phone lines? So then for doing this we need to have two things. To undergo this change we needed two things. Device that could have coaxial connected to it. Second is the infrastructure to support this. Now this device is okay. this device is called as um, cable modem. Could connect coaxial, and then the infrastructure is called as cable modem transmission system or CMTS. Okay, so then now we have moved from twisted path to cable networks. Perfect. Now, okay, that is okay. Good. Now, data transmission schemes, DOCSIS. During the last 4 decades, several schemes have been designed to create a standard for data transmission over the high frequency cable. Prevalent one is devised by multimedia cable network systems called Data over Cable System Interference Specifications, DOCSIS. DOCSIS defines all protocol necessary to transport a data from CMTS to a CM. Okay, now what we did is the CMTS. So we have a cable, we come to residence, then we go to modem. Okay, so then what we did is now the CMDS is not exactly transmission. So the way this works is the way this is to work is I mean, what is the need for CMDS? Why can't we only use CMs? Okay, but in DSL we did not have CMDS. Okay, so now there is one more thing that we need to study here. So how is this communication getting established? Okay, so let's have this thing here. Let's come here. No, let's come. Let's come. Let's see. Let's have a text. Oh yeah. Okay, let's move this thing down. Perfect. Let's go to text. This is something. Let's get rid of this. Change the color. Oh, not fun. Let's add this as unit. So we say, how does communication work in DSL? The thing is, this DSL is on the customer side, right? So this is customers home, and it's, yeah, this is in customer zone. Let's copy. So then it kind of let's just, so from here we go to this. This is like phone exchange or DSLM multiplexer. So is DSLM and phone exchange same? Now do they go same places? Oh, so still okay. So what he's saying is this phone exchange is for phone connectivity, right? So then this we have DSLM. This kind of acts like the exchange. For phone lines, we have phone exchange, and for we have, although both use twisted pair. This is something how the infrastructure is. So the way the connection is getting is using this multiplexer. So now this is then going to send it. So do a copy, do a paste. Click on arrow. No. Select the why is this not getting selected? So shape. Control C. So let's go to text, and then this is another DSL modem. So this is going to establish the communication. So go, let's how this is. Here is this. Yes. Okay. So then this is going to, this is DSL. Similarly, let's, so what we do is, this is at says at customers home we have a cable modem to convert the digital to appropriate frequency used by coax. So then this is going to go this is going to go to this. What is this? This is the CMTS. This is CMTS for establish connectivity. This is on ISP side, and then you have another user waiting here. So this is another user for connectivity. So then this is going to this is on the ISP side, remember. On ISP side. Now there is certain rules or protocols that is at CMTS, which is called as DOCSIS or data over so how the data over cable system interface specification or DOCSIS. So it is basically rules, right? DOCSIS are basically rules to transmit data over coax over cable lines. DOCSIS is basically rules. So this is done. Now certain rules need to be followed to transmit. Okay, so then let's see. This is DOCSIS. So then if we say what is DOCSIS, this is set of rules which need to be followed when we transmit over cable lines. Nowadays we have fiber, that is something fiber to home service. Okay, so there were rules to transmit rules for transmitting over twisted pairs is called. Similarly, there was rules there as well. So that is like it's a twisted pair, right? So you have Ethernet and DSL standards. So if you go here, so if I'm here and I say let's have a text box. So we have DSL standards. So what is DSL standards? These are rules which indicate how data should be sent on DSLs. Okay guys, we learned a lot about DSL. This is the first type of modem no longer used. So yeah, these are DSL modems. You have an Ethernet cable connect. See, only it has two ports. Even this DSL is an phone line, right? It's a cat or twisted pair connectivity. And then we came. So internet came way long back. Cable came before. So if you see how the hierarchy of discovery is, first was phone, then we moved to cable, then we moved to internet. This is how. The in India D2H came late because so D2H is direct to home service. What was happening was you had that anti so that I mean the broadcasting you didn't have the broadcaster is to broadcast it to the satellite. From the satellite is to go to the cable providers um, receiver is to receive that, and then from there it is to be local transmission. So to now to eliminate that um, uh, local so D2H was introduced so that the customer can directly connect to the there is a lag that happens, right, using satellite instead of using the cable providers. So instead of using the cable providers, you directly have a DTH at your home again. Uh, that's all for this lecture. See you guys in the next one. If you want to know when it, oh, let's write the year. So phones was in 1800s, then this came in 1900s. This was more towards 1996 or something. How, if someone wants to know the dates. So right now we are using cable wires to have our internet. This is how it is. That's all for this lecture. See you guys in the next one. Till that time, take care. Bye bye.